For this video, I would like to present something of a technical lemma, I suppose, and it looks like this. If the limit as x goes to a of f of x does not equal 0, then there is an interval about a, that's about the number a, where f of x does not equal 0 on that interval, except maybe at a itself. So let's let that's an infinite limit either. This is a finite limit. So it's the beginning of the proof. Let the limit as x goes to a f of x equal L, where L does not equal 0. Let me sort of draw a picture of how this will work here. Let me also do this. If you give me, let epsilon equal the absolute value of L over 2, then there is a delta greater than 0 with the absolute value of x minus a greater than 0 but less than delta, implying that the absolute value of f of x minus L is less than what would normally be epsilon. I will insert the L over 2 because that is my epsilon. Let me draw a quick picture of this before I continue here. I'll just work with L's that are positive for now, but you can get the idea even if you think of negative ones. I'm going to draw myself a graph with a hole in it, and right underneath the hole, I'm going to put the number a, and immediately to the right of the hole, I'm going to put the number L. That's the limit as x is going to a. Now, if I forced myself to go no higher than L plus the absolute value of L over 2, and I've allowed myself to go no lower than L minus the absolute value of L over 2. So let me darken this region. Let me make it kind of scribbled here I'm talking about. Do you see it's this region from this bottom part here to the top? It's never 0. And if I go to the right from L plus absolute L over 2, find its spot on the graph, and then go directly beneath it on the x-axis, I'll call that the letter C. And for the lower bound here, find out where it hits the graph, and then I'll go down on the x-axis and call that the letter B. So on this interval from B to C, the function is not 0. F of x does not equal 0 on the interval B to C, except maybe at A. See, this has a hole here, so it's possible that they could have defined f of A to equal 0, and that would screw everything up, but it really doesn't because these limits don't care what happens at A. So I'll just say except. I don't even care if it does or not. I'll just say except at A, but I should really say except possibly at A. Anyways, usually when you find these intervals, when you go finding your delta, you look between B to A and A to C and see which one is smaller. In my case, it looks like B to A is smaller, so let's call that delta. The distance between B and A is delta. And then I'll try to copy the same amount of distance on the other side of A, and that's also a delta. And then if you look, I had to modify the right endpoint. So I'll go up to the graph, and you can see that when I go over to the right from that specific point, that I'm still within the range of positive y values. So f of x does not equal 0 on a minus delta, a plus delta, minus the number a itself. So I will be using this technical, I guess you'd call it a technical lemma, to prove the next limit that I want to do.